Hello. I am Chris from Airwindows, and we are getting back to sort of our old school plugin coding after a whole bunch of fooling around with people's other plugins. Things like Sign Machine and Six Signs and Audio Damage, Circa, and Descent. And all of that was good, but I've got some stuff that I need to do. And so today it's going to be me seeing whether I can do it. I'll see what I get. I thought I'd fill you in a little bit on what's been going on, though. For instance, I have a little folder here. Let me pop the chat out. Hey, Chad. I didn't pop the chat out yet, so I didn't see anything yet. Yeah, it is Thursday. It is closer to the weekend than it was on Wednesday, at least. So what might this thing be? It's a little folder called Work. Well, check it out. This is what I was doing this morning. I went through and ripped a whole bunch of CDs to my computer, because I came up with a way not to say that that was a Splendor first thing, because it's like, no, I knew perfectly well I could do this. To have this stuff measured in meter and then bring it in my car. Because normally, if I try to put stuff like this in my car, it's unbearable because it doesn't balance with the vinyl records that I like to listen to. Most of it is all far too loud. But my audio editor, Twisted Wave, normally goes through and does things like makes my MP3s for me to put on the car thingy. I make them in 320K. Still isn't really quite the same, but I mean, in a car, it doesn't really matter that terribly much. And what I can do is take something like this. Here, we'll do a quick little meter. As you can see, this track is kind of loud. But the reason that I went and grabbed so many, like look at all my King Gizzard stuff. I ended up with a lot of King Gizzard CDs, and I also bought Omnium Gatherum off of their Bandcamp. This is a bunch of really good King Gizzard, but it's also often very much like this. So one thing that I can do here is fire up meter. I've got it on shifting of bits. And as you can see, it's very distorted, but I want to see what the measurements are for these things anyway. I'm not going to do more than just one. I'll do this one and I'll write it down and I'll move on. But I have been capturing so many things off of what CDs I had for the purpose of doing it, because what I can do is go and check out, for instance, like some of my loudest Beatles are a pretty decent example of how loud you can reasonably get for like listening to stuff in the car. Stuff like the Sgt. Pepper's Reprise or Birthday off the White Album. There are a bunch of things like that where they pretty much push as hard as this. Although, actually, no, I'm not going to play it through. It would just blow up your audio. But I want to see what this stuff does. I want to see how it behaves. And I recoded meter to be able to cope with this kind of thing better. I recoded meter so that it was tracking way more in terms of what was actually happening during, like, see this giant red spike? That is 100% pure clipping during this entire time period, which is like 5 seconds. 5 seconds where not an instant wasn't anything less than full clipping. That's kind of horrible. But this track is Big Fig Wasp, which I believe is off of the Flying Microtonal Banana, unless it's off of, what, Polygon to Wonderland, maybe? I don't remember. Another thing that I did was I took everything and ripped it off of the CDs, which gave me stuff isolated to individual tracks. And all I had to do was change the names from like one audio recording, numbered audio recordings with no names to them. And all I had to do was go through and type all of that stuff out. So I typed all the names and I gave them the band identification there as well. And then I'll be punching in these meter measurements this entire time. I've got a long way to go before I have all these things measured, but this is kind of what I have in mind, is being able to take a track like this. Actually, I think I can put the content hiding on, make my gain control be a little bit more visible. And that gives me a bit of a sense of what this is like. But my plan for this is I'm going to measure all this stuff so that I can have that available. And then I'm going to use Twisted Wave's batch processing to make the MP3s out of all of these. We're looking at an effect stack which looks fairly similar to the batch processing. But the batch processing will let me normalize the track to LUFS. So what I'm going to be doing is measuring what something like birthday or whatever, something that I know is loud in the car, what that gives me LUFS-wise. And then I'll force everything to be normalized to that, just as part of the making an MP3 process. I won't let it turn anything up, but I'll turn all of these things down. And then I'll be able to listen to the music, even if the mastering is completely unbearable. All that will happen is it'll be about the same volume level as everything else that I listen to. This is a particular track. This is Big Fig Wasp. I don't remember what album it's off of, but it's off of one of the albums that is just slammed beyond all reason. Sometimes they are, sometimes they're not. They very weirdly, Infest the Rat's Nest is not as loud as that. I'm pretty sure that it's Polygon Wonderland that's one of the super unbearable ones, which is a shame because it's the super proggy one. And Flying Microtonal Banana is also pretty loud. A whole variety of them, they wander around through unbearable, not as unbearable, so on and so forth. So let's see, that was Big Fig Wasp OEA. Capital O. Oh wait, no, it wasn't, was it? Hang on. Back to here. OAEA. Okay, so I almost had it right. Usually I'm able to focus a little better. And that means that the fullness and the loudness is just pinned, maxed out. Dripping Tap off of Omnium Gatherum is also incredibly loud. Rattlesnake off of Flying Microtonal Banana is extremely loud, but again, stuff like Mars for the Rich, Organ Farmer, off of Infest the Rat's Nest, ironically, isn't as loud as all that. Here, I'm going to load up Polygon to Wonderland. You can kind of see what this is about. We've got a drum intro, and then by the time we get to the end, it's really, see, the white is full loudness going out to the outside edges of things. And if I was to go away from here and go over to here, maybe not that. I copied over a bunch of Bob Marley to measure and calculate as well. Also, this Dillinger is off of vinyl. I have Irony's a Dead Scene off of vinyl, but I had the Running Board EP and Calculating Infinity on CD. They're also pretty loud. And I get to measure and analyze all of the Dillinger stuff too. Let's see. Metered. Most of which is not. But we've got some Beatles tracks that are. Also, I have a Beastie Boys CD, which I'm also going to measure everything about. What you see there is off of Paul's Boutique, which I have in vinyl. And let's just try to find my loud Beatles track that I would like to use as a reference. I don't think it goes quite up to, well, Taxman is a decent example of that, but I'm thinking more Birthday. I don't know if no, I do. I surely do. Yeah, so that one is so loud that it didn't even rate all that high. And you can see it's pretty intense. But if I play this in the car, it almost makes me turn the music down because so many of my vinyl records are way softer than that. You can see why. I've talked about this. I've talked about you can get this like 60s loud quite easily. All you have to do is make everything peak in the top 6 dB, and it'll come off as loud. It'll come off as loud like the other stuff is loud. You're not gaining that much by limiting and clipping everything. So in the car, this one is loud enough that it kind of almost forces me to turn it down. It's kind of annoying. And I want that to be my limit. So rather than continue doing the effect stack stuff, I'm not going to do that. I started a little bit late today, so we're going to do real coding. But what I'm going to do is analyze. Because this will tell me what the LUFS is. So global minus 12.77. So that could be we could call that minus 13, maybe. I'm going to write it down on one of my little note cards. Or why not just take that literally? But I'll go even a little harder than that. I'll go minus 12.75. Oh, I should also write LUFS. I've been doing so many things that it's easy to get discombobulated. Not unreasonably, though. Like, I have to put a lot of work in to dig myself out of my financial hole, and so I attempt that in reasonably good grace, I think. So here's what happens when you go for something like, what was the... Let me see. Oh no, the one that I measured. So I don't remember exactly what this is off of. I think it might be off of Flying Microtonal Banana. I don't remember. Can't listen to enough of it to tell whether it's all microtonal and stuff. But here's what we can do. We can do a normalize, and we can normalize to minus 12.75 LUFS. It has a maximum gain and maximum attenuation, which wouldn't be a problem. Maximum peak value will also let me restrain things a little bit. I get to use true peak, but I'm not going to. And then the maximum gain means, can it turn stuff up? And I would like it not to. If something is already quiet enough that it would be turning it up to match. I don't want it to do that. I care about crest factor, but this is about restraining unpleasant and obnoxious tracks like this one. So that's something I get to batch run. And instead we're going to go minus 12.75. We'll go LUFS. I'm not going to want to cheat channels independently. And I feel like those settings are good enough. Normally I normalize to the peak because it's vinyl records I'm working with. But when we do this, look at how much quieter this has to be at the same apparent volume as that Beatles track. If it had peaks, they would be poking out nicely and it would sort of fit and balance. But what I can do is, and the interesting thing about it is I can make it into an MP3 and it'll grind and clip less on the reconstruction because the reconstruction will generate like true peaks. But that won't be a problem here. In fact, I can even demonstrate that while I'm at it. This is purely just for the sake of showing what it does. So see how flat that is? I'm doing a 320K MP3 much like I'm going to do. And we've got the slightest little fuzziness, which can probably be highlighted by expanding this window a slight amount. Yeah, see it's a little bumpier. The edge is a little bumpier. And that is because the MP3 is also where you will get reconstructions that like go above true peak and so on. And this will stop the playback system from hard digital clipping on the edges of anything that's here. Like for instance, there's a little nubbin there, which clearly is a pointy high frequency edge, and that pokes out beyond everything else. So under some circumstances, that would be clipping right off, but I don't have to worry about that because it'll be fine. And then I'll throw that away and we'll move on. But yeah, I have been in the process all morning of getting all of this stuff so that I can work with it. I've already done the beauty pill, although I have not yet done the beauty pill is not as loudinated as something like that King Gizzard record, but it's still more loudinated, so it still poses me a problem in the car. If I'm listening to it, just pleasure listening, it will always come across too loud because it's in the age of loudness war. But also, carbon-based life forms also is going to need to be normalized because pretty much all of this stuff, it's nice sort of chill, space ambient kind of synth music. But yeah, it's kind of, see, even if it's not quite to the iron bar because they are trying to avoid having nasty intersample peaking or whatever, it's still obnoxious. Like if I do my content peak on here, this is what loudness war stuff looks like. They're getting lots of heavy bass, there's lots of fullness, but we're sitting at the loudest possible sound kind of more than we really should. Ooh, nice theory of mine. Yeah, I have a bunch of boards of Canada, but not that one. I went through, and a bunch of this is not going to be, like that's why I have a maximum gain boost on the normalization, because a bunch of this will pass through without actually being turned up. But I've got everything but the EPs and the new record. And I'm looking forward to seeing how some of this stuff measures because I've only ever measured the stuff like 1969. I have measured, let's see, which other one? Not right there. I could have measured Roy GPIF, but I haven't. Now I'm trying to remember which was the one. There was one of them that I measured, and I know that I did. Dawn Chorus. Yeah, Dawn Chorus gave an incredibly high rating in a previous version because all of its sounds, and again, it's another one of these like bordering on being over loud. Not really, but it's pushing its volumes. But look at what the peak colors do. Dawn Chorus has almost all of its noises as that perfect balance between peak and slew. It's got that sort of roaring, dark quality about it. So it just, if the blue loudness dots are the ones you want, it's loaded with them. It has all kinds of stuff going on there, which is not the case for all of this stuff. This is all towards the purpose of me eventually being able to do a better documentation on all of this. But I got to go through and measure all these things first. I've started measuring some of the burial. That's also going to be another one where I'm looking forward to being able to throw, and certain ones, here's other CD. I'm probably not going to bother with Livin' La Vida Loca or the Skrillex, even the noisiest Skrillex, because I just don't enjoy that much to listen to it in the car. I do enjoy some of the Asa bass, but it did not really show off high performance this time around. It was a little bit too intense. I had 2 CDs from Massive Attack, so that's the Blue Lines and Mezzanine. Again, here's the Dillinger. That's going to be fun. That's also going to be desperately needing me to do the normalization. Otherwise, it'll just be too upsetting every time it comes around in the rotation. Here is a more recent prog band, which I really enjoyed the music of. Unfortunately, you got this. So it needs to be normalized, otherwise when it comes up in my rotation next to vinyl record sourced things, it's just excruciating. And so I've never been able to listen to this before, even though I like the music, but the sound is so appalling that I can't really deal with it. And yeah. Oh, Andrew Ship said the loudness wars are over because I won. Fair enough. Oh, look at all the Depeche Mode I've got. This is basically all from CDs, but I was able to find all the really old CDs. So let me, for instance, load up something suitable. Funnily enough, like some of these ones, like when I say old CDs, I mean this. This is off an old CD. Notice something? It's not peaking. You could normalize this. In fact, I might need to for some of the measurement purposes. I might need to normalize it as if it was a vinyl record in order for it to measure it reasonably. And I guess shut those things off while I'm at it. Because if we do that, much like me capturing a vinyl record, it got just a tiny bit louder. And we can go and find the hottest peak, and it's this one peak out of the entire song. My Depeche Mode collection off of CDs is not like the more recent CDs. And then a classic track off of Violator. Here. Looks like we do have a peak off of that. This is off of the CD. This is an old CD of Violator, where it has that one sound in there, just on one of the channels. Just their electronic percussion or whatever lined up in a certain way. And it made this. This is the Depeche Mode track, Enjoy the Silence. And it'll be real fun to measure this and see how this one shapes up against the vinyl records, because it's competing on the same playing field as the vinyl records this way. Like, for some of the older CDs, you get that. You get to do stuff like this. You get to have it set up where if it has peak energy, you get to experience it. And here's a later track, Condemnation, off of Songs of Faith and Devotion, I think. Same deal. In this case, the loudest peak just barely goes up to here. In some of these cases, what they're experiencing is what you experience when you're working with the DAW, which is if you do digital mixing. I don't think they were necessarily doing that, but it was in the realm where they were getting able to use digital recording, which isn't to say that they were doing it. I didn't really keep track of that. Some of this stuff was done in analog recording. Some of it was done in big analog studios, but they had a digital multi-tracker or whatever. One of the first machines able to do that was like Funky Town, Lips Inc. And it was so trendy at the time. And of course, this is the era where everybody is mastering to digital tape at this point, like the Sony Dash or whatever. Some of the first examples of that are like the Police's Synchronicity. That's well earlier than this. So by now, everybody is mastering or doing their mixdowns to digital tape so that they can have peaks like this in the middle of the rest of their music, because they did not know yet that they would end up clipping all of those things off. So this is a CD that came from the era where they maintained all of those things. And it's just all still there. And so it's going to be fun to measure all this stuff. And we've got other older CDs. I don't know just about everything is like, will require some normalization. I could probably run a normalized batch process on this entire collection, as I've still got the CDs in case I wanted it back. But yeah, and Oasis is loud on purpose. Oasis did that on purpose. Yeah, I've got Godspeed to You, Black Emperor. Oh, I don't know why I called it YBA though. Let's change that. That's a simple typo, if I'm not mistaken. I have only one Primus album, which is the Desaturating 7. I grabbed it though. I got only one Orb album, and you can probably recognize which one that is. A double album though. Only one VCMG album because they only put out one album to my knowledge. And yeah, it is going to be interesting going through all that stuff, measuring it, and then being able to do a batch process of making MP3s from my car, and then straight up bringing them on the road with me so that I can actually listen to them. And if stuff comes up and it's like, oh, that sounds horrible because it's at the correct volume, but it's completely squished, then I can always hit skip. But I would like to be able to hear that. And that's interesting, Jonathan. I didn't realize that Vlado Mellor got it from that. Anywho, we're up to a different thing today. So here's where I'm at. I've got some of this stuff up and running. I am sort of in the process of getting ready to do Purist Console 4. We've also got Console X3 ready to build in these early forms. Also, you'll notice channel X. Here's the thing. A guy that I know in the industry did an ADC talk, that's Audio Developer Conference. I did not go to this conference, although honestly it would be fun if I ever did. But at this time I didn't go to this conference. But it's on the internet and stuff. And he was developing a thing called elliptic blep aliasing suppression. And it is a zero latency aliasing suppression. So that immediately got my interest. There's a whole video of it. I don't have to get heavily into what the video is about, but we're going to be walking through some experimentation along those lines. And I probably should open up MacAU here so that I can sort out what I'm trying to do. So we've got a build of these things, and we're pretty close to having a build of Spiral 3. But that's because I did a version of Spiral using the technique from longhand. And that's very much on purpose. That's exactly what I wanted to do, is start putting this together. So what we've technically got here is the previous optimal arrangement for how to do this. And that is, we've got spiral here. We've got density here. Both of these things are being implemented using the technique that I'm using for longhand. It's simply a sign calculation that is being done just using a Taylor series expansion. And that might sound like difficult math, but honestly, compared to most of the people that I'm hanging out with, it's not. It is actually very simple. It just, if you know these numbers or can go and find them, then what a Taylor series expansion means is, as long as you keep adding and subtracting this as it goes to higher and higher powers of itself, you're reconstructing what the sine function does. And it exists for other things as well. But what makes Spiral interesting is that for Spiral, we are multiplying the input by itself, which typically will scale it way down to tiny values. Then we're running it through the saturation. Then we are dividing it by itself, unless we're not, because if it's 0, you can't divide by 0, but if it's 0, then the output is 0. So there are various ways of handling this. Another way that I can do it is simply, if the input is 0, then I don't do the calculation at all, because the output's going to be 0 anyhow, so why bother? But in this case, this is the spiral algorithm, and all that is it is a sine function in which I have skewed the saturation of it so that it saturates more as it gets louder, and it saturates less and less as it is quieter. And the hope there, and I think it worked out pretty well, which is why I'm so interested in extending it in this way. The hope there is that with a sine function, you have a rapid change in curvature sweeping through the 0 point. And watching videos by Frail Homer on splines and things really brought to my attention why it is that people don't like it when that happens. I had a plugin way back in the day, an early version of, I guess it was, I did an update on channel, and people hated it so much that I had to roll it back. And ever since then, I've been doing variations on channel that basically kept everything the same. Because I did a variation on channel that has the same distortion part that is in Crystal. It survives in Crystal. But what it was a way of extending the flat and uncolored version of saturation, like a window where below a certain amplitude there was no distortion. And then it was meant to transition smoothly between that and starting to do the sine curve. And the part that I didn't understand, even though I could get it to basically work, was that as you do that, you're going from a no distortion point to the curvature is the sine curvature instantly. You move past that point and the curvature kicks in very suddenly, even though the amplitude, the amount of distortion, doesn't actually change at that point. What has changed is the curvature hits. And this is a spline-related thing. This is a thing where people are sensitive to that kind of behavior. And again, the result that I got was I made it, I thought it was going to be the coolest thing ever, and everybody absolutely hated the sound of it. I was calling it new channel, and then I was like, quick, restore classic channel, and which I did. And then, but that's why I think it's interesting doing Spiral. And Spiral is specifically about making a continuous gradation between maximum curvature at the top and zero curvature at the center. It might also have elements of TAPAC in it, because TAPAC was specifically designed so that it would have like a reverse curve going through the middle, a bias-like behavior where the amplitude wasn't going to, there was going to be a small suck out in terms of like expansion at the quietest parts. And that I got from, oh God, what's his name? The T805 guy. But what we're looking at here, we've got this, and then this is my filtering. And the filtering is doing a particular thing. So I think I can also build this. Maybe I'll want to do my testing in Spiral though. But see, I could run with this. We could simply use this. And this is the same filtering that exists in TAPAC and is there to do that subtle high frequency compression thing. But Signalsmith was working on something else, and it has to do with this kind of code. Because for a very long time now, I've been experimenting with this sort of flip technique. All of the high passes in any version of channel are interleaved high passes. It's two separate high pass filters, one sample apart. It just seemed to me like it would be a good idea and would work. And in terms of being a relatively shallow high pass that you barely notice because it's only removing the very, very lowest frequencies and not really much of those, you don't notice that is happening. But what was happening with Signalsmith's paper on elliptic blep is there's a technique that you can use where you can keep track of, for instance, here, I'll go over to Spiral and we'll start putting this together. I could also do one for just straight up hard clipping. But I think what I'm going to do is I'm going to do it in here. You can also see that this is a raw materials plugin that I've just started because it has 26 controls on it so that I can use as many of them as I want and then rename them later. And they all go between 0 and 1. And so what we can do is build this. I have also got a Bezier smoothing in here, which I guess I just decided I wanted to have that. I've been putting it in things more and more often. But what got my attention is the extent to which these things kind of resemble each other. Let me move that over there. So today, and who is to say whether I'm actually going to get anywhere with this? But, and I'm being very good. I didn't guzzle too much coffee. I'm still drinking coffee at 1:15 in the afternoon, but I have not had 12 cups or anything like that. Because you can't force stuff like this. The hope is to experiment with this method of aliasing reduction. And I'll tell you exactly what I have in mind. So Signalsmith came up with a way of using essentially stuff like what I'm using with the IIR filter, stuff like what I'm using with the interleaved, because if you are interleaving samples, you are making a thing happen at exactly the Nyquist frequency. That's what you've produced. So if you have an IIR filter that filters away stuff, and you're using it to create the, honestly, I should really bring up the, give me a second, this won't take me too long. It is not music, so I can get away with playing this. At least I'd be shocked if I couldn't. So Geraint Luff is the dev from Signalsmith, or at least that's the name he goes by. Smart guy, does good work by his plugins.
Which is a wonderful principle of them.
And he's building this stuff. He's talking about polynomial waveforms, but I do not care about some of those details. And we'll skip ahead. A polynomial waveform is a thing where this is your waveform, and it has this discontinuity. So it's like synthesizing a sawtooth wave like this. It goes up, and then it suddenly transitions to here.
Practice. So, this is a very short waveform made out of polynomial segments.
Polynomial segments means it can suddenly transition from there to there, even though audio in digital audio can't. You can't do that in any Nyquist limited digital audio, nor if you had that in real world space and sampled it, you wouldn't get that out. You would get a little slant there and a wiggle on the outside edge. So that's not something that can exist in a sampling system. But that is the hypothetical value, and that's what you can naively generate in like synthesizers and things. So if you are in a sampling system, you would sample that, and the data you got would be more like this. If it was up around the sample frequency, because this wiggle, if you were up at the Nyquist frequency, the up and down of this is literally at the Nyquist frequency. You'd have one sample there, and then one sample there, and one sample there, and one sample there. This would also apply to the Bezier filtering, maybe. I don't know whether it would make sense. But if it was applying to the Bezier frequency, then you'd be applying that to the internal downsampled wave. And if that makes any sense, then there is reverb quality updates in store, which, given that I have so many reverbs to do, that would be exciting. Because then that would track DRes. That would apply to my Bezier EQs, all of this kind of stuff. Anywhere, oh, does he have free plugins? That's very nice of him. I didn't know. So we're looking for discontinuities. If you have a Nyquist limited frequency, a Nyquist limited system, you can do these shapes. But then if you have these corners, that ain't happening. you cannot capture them. And what he is showing here is a point where the data isn't actually changing, but the rate of curvature is changing very abruptly. And that's the thing I was talking about before. So we're looking for places to identify stuff like this, like a super discontinuity here, which can't possibly exist in a Nyquist system, or just points where something changed. So notice one thing about this. If you were doing a high-pass filter, like for instance, slew only. Slew only is, how different is the next sample from the previous one. And it'll store that. So if you ran slew only on this particular one here would be a giant bump. And then you'd have a slight edge there and perhaps there, where slew only would highlight that, whereas slew only would not do anything on the flat edge there. Or it would be a tiny little change, but not much. And wouldn't do much for the slow change here. So the idea that he's working on here,
which is the negative of all the bad stuff, essentially. But this waveform here on the right is something we can stamp onto our waveform. At every point, there is one of these discontinuities.
So what he's talking about is, here's where the samples suddenly jump, but this is what they would have to do. Consider that all of those wiggles are at the Nyquist frequency. So we're basically talking about like, here's one point, then here's the next, and then here's the next, and here's the next. The wiggle is going to be your cutoff frequency. The steeper it is, or rather, the steeper the filter is, the longer the wiggles have to persist out from that point. If you did stuff like, and this is something that's really important to me, something that I'm going to be working on today, and I'm talking my way through it. When you do like notice something about that particular wiggle, it goes in both directions. That is a linear phase filter. I don't like the sound of linear phase filters. I absolutely do not. People get bugged by various things in audio. That's one of the things that bugs the heck out of me, which I don't like in the sound of digital audio in general. And when you implement stuff like this is why I begged Bacon Paul to successfully begged Bacon Paul to retain his original filter for 6 signs as an option, because he had come up with an original filter, like I think A equals 4, I think it was, that was just like 8 samples wide. Just only that. And he was able to make it so that it did a pretty good job of getting rid of supersonic sounds with just 8 samples to work with. The idea was to do it CPU efficiently. There was a problem. I thought it sounded fantastic, but it didn't sound exactly the same at every sample rate. And I was immediately doing stuff to exploit the tone of this filter, and immediately found out that it wasn't acting the same at every sample rate. Upon learning about this, Paul and a bunch of other people in the Surge forum were like, we need to throw this away and only use the thing that is perfect. And they went with the thing which was perfect, which was a much broader, like over a wider window, steep brick wall filter, which means that for the filter they were using, it looked like up here, where there are the wiggles at the Nyquist frequency, and they stretched out for way longer in either direction. And in doing that, they were able to make it sound the same at any sample rate. And I thought it sounded bad at every sample rate, because the pre-ring of it, like this, there was an unpleasant quality to the way that it sounded, even though it was perfectly consistent now. And I liked the one where it sounded better to me, even though it wasn't consistent at every sample rate. And here's how that kind of thing works. Is the steepness of the filter will produce this. This is like a hypothetical perfect filtering. We're taking the corners out of it, and if this is how our samples are spaced, this is what you have to make it be if you're literally taking out only the samples that you need to take out, only the frequencies that you need to take out. You are left with that ripple. It's not an overtone being added. It is literally exactly what the waveform is when you subtract that stuff. But also bear in mind that what I'm doing with my Bezier stuff is at all costs trying to make it so that the vertical part of it can be as steep as this is, and then it draws a neat little corner and then is immediately flat again. Like all my Bezier stuff is trying to do things like that. It's trying to not have the ripple, which technically means my Bezier stuff is not correctly brick wall filtering at all. And I like the sound of it better, and I'm willing to run with it. So with this perfect blop idea, what he's doing is demonstrating the fact that if you wanted to take this and then do a filtering with it, where you could just capture the audio at any point and have the perfect like downsample where you wouldn't have aliasing ever. What you could do is take this and then overlay that onto it. And if you added this to this file, you would get this. It would exactly reproduce this from just adding this to the sharp-cornered one. It is the sort of anti-filter pattern that you'd add that to.
You can shift it around in time. You can scale the amplitude to match the amplitude or the distance of the discontinuity.
That's the next important point. Because here's the thing. Like, you don't necessarily have that sitting on all of the sound. You don't have the entire sound ringing constantly. You're chasing points where there's a sudden discontinuity or a sudden change in the audio. And we can measure that because we'll get to where he's going with it. Like, this is the blup thing being added. And then he's calling to our attention the fact that this is the big discontinuity, where there has to be a matching discontinuity in the opposite direction. But this is also a sharp corner. And you can use this technique. It's not a discontinuity, but it is a place to put that kind of ripple effect and cope with the fact that there's a high frequency thing in there. If you apply this technique, and note that it is a technique that is bidirectional, he's doing, in this example, he's doing it as a phase linear. But it's technically not really even, you don't even need to think in terms of phase linear or whatever, because it's not really quite a filter exactly. It's like a separate thing. It needs to be able to check for whether these sharp corners are happening. And it's looking at it at a higher sample rate, for instance, or just watching for when something like that is occurring, and then we're adding that to it. So in terms of related problems, continuous versus discrete time, we're working on stuff that is already sampled. So technically, we don't know what lives behind these sample points. They're not stair steps. That's not how this works. But we've lost all the information. There is no way to tell what lurks behind this, except that if what produced this was some kind of high frequency waveform that does like what my mouse cursor is doing, and it just happens to catch those things, we're going to be wanting to filter that end result out. Like if there's something that is going way faster than that point, then the output that we're going to want to generate is not aliasing that high frequency thing down into lower frequencies. We're talking about digital wave shaping.
Then this first half might be familiar to you because you say, okay, I've got my signal, I'll linearly interpolate between them, and then I'll stick the continuous time version of that through a wave shaping function. And then you might think, oh, well, this segment between these two samples exactly matches this segment of the wave shaper, and so I can use the integrals and stuff to find out these samples. We're not doing that, okay, right? We've got
apparently that does not work. It's not a thing.
This polynomial problem, then this gives us quite a nice way.
Pretty sure what we're looking at here is like points and then like control handles, which is similar to my Bezier stuff, which is just splines. I'm just running with splines for those things. So the idea, let me see if I have a better example. Here's a good example. Hard sync synthesis. He is showing a picture of a primitive form of sawtooth with a phase reset. So this wave is going and then it will snap back to the beginning again when sync kicks in. So that is a particularly bad example of something that's going to cause way massive aliasing. This is another thing that got my attention. Holters-Parker resampling. Honestly, I don't know what that is, but continuous time one-pole filter. Remember how I was showing the high pass that lives in channel? The high pass that lives in channel is already a interleaved continuous time one-pole filter. So what Doreen is doing here is talking about the uses of an IIR filter for this particular thing. And you can feed additional information into the filter and it'll diminish here and then kick itself back up again. So you can use one-pole filters rather than linear phase filters with the pre-ring. This is still a way of doing this, just possibly not quite as effective. So he's talking about summing multiple one-pole filters. I don't think I'm getting there. One of the reasons why I'm not getting into that is because, again, what you see, rather than it being a clean filter that starts at the point that you want, with multiple filters along the same line, you wind up getting this very delayed result. And I've done things like this. I have done things like stacked large numbers of very primitive and simple IIR filters on top of each other. What I found was you take the simplest form of IIR filter and you do like 20 copies of it in series. It still doesn't get rid of that much in the way of whatever you're filtering. Like if you're using it as a high pass, it doesn't really take away the lows as effectively as you'd want. Just stacking up more of them doesn't do that great of a job. It also doesn't resonate that hard, but you'll see there's a delayed behavior in there, and I've generally not really liked that. So impulse, and then this is the stack of filters that he was doing. There is a problem, which is that apparently when he's trying this stuff out,
low pass step function. That'd be cool. Let's try it. So the way we do this is, again,
so he's experimenting
we've got it
with
as
this
the parallel sum of one-pole filters. And one-pole filters, being exponential decays, are incredibly easy to integrate. You just multiply them by 1 over a, whatever a is. Your like decay factor, which might be complex, but that's fine. Yeah, so this should work. This should work, right? You can see that if you integrate them all individually, then ideally they'd add up to produce
So there's a gotcha he's building to.
this band-limited or almost band-limited step on the left. Unfortunately, this almost works, right? So we've got our original one. This is the actual implementation from my C++ code.
Now the specifics about this?
And yeah, the blue solid line is the impulse response. So I've got all these filters running, these one.
So essentially what he's saying here is he tried to run the filter directly on what was being done, and it failed. And the reason it failed was because he needed to build in a high-pass filter.
Your value. I mean,
So this is him trying to do it even more, or more layers of it, and it would get worse and worse.
I was expecting, and it has the inverse response, but differentiation goes to 0. It has non-zero about this. We're going to high-pass it.
This is the point that I have not ever had with regard to the stuff I'm fooling with.
So if you apply any high pass, then it will have a 0 amplitude response at frequency 0.
Yep.
If you apply
Slew only
a
would work for
Butterworth
this.
high pass, for example, a high order one has repeated zeros, has lots of zeros, like stacked on top of each other.
Slew only is a
0
low
hertz.
order.
So it's very 0 at 0 hertz. As engineers, and this is our filter response plotted.
And
as a
he has
spectrum.
tried it.
And I've designed this as an elliptic low pass.
And that's what he was able to get. Look at that amount of cancellation. Like between 20K and 24K, it's dropped way the heck down.
So these are the impulse responses that we've now generated. That one zoomed out in time and frequency. They do, in fact, offset. So how do you use one of these things?
A fair question.
Well, you've got your current waveform output, and then you encounter a boundary to the next polynomial segment, and you say, well, is there a discontinuity? No, there's not. Is there a change in gradient? Yes, there is. So you add in, you give your filters the appropriate level of kick responding to a singly integrated thing proportional to the amount of gradient change. And then you just carry on, because actually the filters, as you can see, are going to handle this ramp up. Like, you don't have to do anything other than just tell it about the boundaries. And then you carry on going until you reach a discontinuity, and then
this
you
would be a
give them
really big
kick in
thing
the other direction,
fed into the filter.
different weightings. And you continue, and that's it. So let's just have a quick look at coefficients. So
here's where I can't follow him. This is a programmer, professional grade programmer, so all of this stuff I'm like, woof. This is a bunch of C++ stuff that's beyond me. It is a C++ class. That's all very well. I believe he is trying to sell his stuff to people, or at least looking around trying to find ways of doing it. But look at that. Parallel 1 poles, A, reminds me a little bit about what I'm doing with the interleaved filters, which are parallel 1 pole filters. So what I need to try, and what I will be trying today, we're going to be putting together a way in which I think probably the best mode here is to be checking for clipping. So what I'll do is I'll take the output a spiral, which is what I'll be working with today, and compare it with the dry output and measure how much of a difference there is between the one and the other. Then I'm going to be storing the previous sample of how much difference there was between one and the other. And I could test this very simply by doing just a hard clip. Straight up do a hard clip and see if I can find the magic formula for making it go away. But the idea is parallel 1 poles. I can do that very straightforwardly. And feed this energy that comes from stuff changing from sample to sample, rather than just tracking this way. Feed that into the ringy 1 poles and then have them attenuate. See how they're dialing back a little bit? I can just divide each of them, like I'll multiply each of them by 0.5 every step of the way. They'll fall back quite quickly. And I want to see whether I can get a useful aliasing suppression out of something as primitive as that. Because here's the other part. This is still going to produce ringing at the Nyquist frequency. The thing is, if I can make it track this kind of stuff where every little thing that happens kicks off this like ring that is fighting the extra harmonics that are being added, the stuff that's beyond the Nyquist frequency, if I can make the ringing kick in such a way that it counters the aliasing that's happening, then I can do that for all manner of things. And that'll be extremely exciting. And I already know that I have I can do a interleaved IIR filter that's at the Nyquist frequency. So it's just a question of, can I make it do this thing? And here's an actual example. We don't get to hear it, mind you.
The lower oscillator resets.
He's got a triangle wave here. It's got a hard sync. You kind of maybe see a little bit of rippling at the top corners or bottom corners. It looks the tiniest bit rounded. But here's where a hard sync happens, resetting it to exactly 0. But what's happening is the Nyquist frequency is ringing, and that's exactly what that ripple is supposed to look like. If you have perfectly removed the aliasing frequencies, you get to sort of do it, you kind of force it to happen. And it's happening for each of those resets. The technique really works. I mean, Bacon Paul swears by this as well. He's using some of that stuff in, I think, a recent Surge thing or something. And you end up with this behavior where this is him taking that situation, right, where you've got the reset and the waveform goes down here, and then it's a hard sync that snaps to 0.
Same waveform. This blue one is at 44.1 kilohertz.
So that's a 44.1K. And then the dotted line, he synthesized at like 384K using exactly the right filter. And you see that the 44.1K, which is like this point and 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 so on, is perfectly emulating the frequency that you would need to have if you were going to simply resample it and do a really proper sample rate reduction. It forces the same behavior out of it. It tracks perfectly. And you end up getting a frequency response in the triangle wave with the hard sync, which is like this. Rather than reflecting backwards into here again, which is what would happen if there was aliasing, it neatly stops that happening. And he does say, no way to include non-polynomial elements. To me, that's quitter talk. We're going to see if we can run it through literally everything. And we're adding aliasing cancellation, whether it fits or not. And I'm going to see whether I can make it happen. And he's got GitHub code, but I'm not looking at it. I'm making stuff up from scratch. Because what I'm doing is not necessarily as well thought out as this, but the basic ideas are very exciting to me. And yep, Geraint Love, Signalsmith Audio. Definitely worth your attention for figuring out how to do this stuff properly. But here's why I'm interested in not doing it properly. the thing is, it's not unlike the way that Bacon Paul was doing correct filtering in 6 signs, and I needed the old version of the downsampling to still exist. Because sometimes when you do things properly, what you're doing is you're making a trade-off without knowing it. And this gets a lot of these guys every single time. They will know, like, oh, hey, technically for the best sound, you don't necessarily want to use ultimate downsampling, because ultimate downsampling is like the 1024 wide linear phase filter, which is incredibly sharp and goes right up to the Nyquist frequency, and we find that that doesn't sound as nice. So you should use the normal one. But all that means is, yeah, the entire direction you're taking with the linear phase filtering and stuff has its own sound and is producing its own compromises. So I'm going to see whether I can do something completely different. And we'll see what kind of compromises that has. And it starts here. So what I'm wondering is whether I can make a enum and start having some variables to fool with that'll help me do what I need to do with this. I know I'm going to need to have a IIR filter and a interleaved filter as well. So we can do something like that, I guess. So those can be the filter that we're maintaining. And I don't know yet whether I'm going to be wanting to slew only those against the previous sample or the previous sample in that filtering. Hey, frog in a well. So there is much experimentation to be done there. I am going to do a total, though. And we'll use the same basic framework for how this stuff goes, and we'll run from here and see if we can get anything happening. And that's the stakes of what we're trying to do. Is we're trying to do... Ooh, I just realized something that I can do in here as well. So I'm going to want those because those are persistent values that are rapidly oscillating. I'm going to maybe once it's I don't think I get to fool with the enums, but I'm going to want to have a binary in here. I'm going to want to have a Boolean in here, and I don't actually get to have a Boolean in here because they're doubles. Or at least the way I'm going to implement it is going to be doubles. See? Do this, and now I have a little bitty array. So I'll be able to use blep blep IIR And I'm going to be looking for other stuff also to use. One of the things I want to do here is include other variables I'll be using in this. So we'll start with I can do that, and then we are storing a previous sample to compare the current sample with. And then we get to also do all of these things relative to what the distortion is doing. So I can get that up and running pretty straightforwardly. I'm going to have to go and hit the restroom briefly, but first we're going to start with this. And that ought to do it. Assuming I remember, yep, double blub blub total, that's correct. So, I don't think I have a pad on the output here. No, I don't. We do have, let's see. So now we're using variable A. And then we can also use variable C to pad on the output. If I do this, it should still build, but not have any warnings anymore. Got there. This is the Bezier smoothing for the controls. Actually, give me a second. I'm a little bit distracted, so what I need to do is get some audio going for you so that you're not completely bored, and hustle off. And I will be right back after having done that. And let's just also show the console X metering, just so you can get used to what that does too. And I'll be right back, but I have to run and take care of business. Oh, looky there, I have to reset this thing, don't mind me. The way I make this work is by setting it to something and then setting it back, because OBS sometimes just does that. All right, second try. Oh, I had it on bit shift. I had it on the silenced. Never mind, I bet I sorted it out now. I'll be back in a moment. with that. Maybe I will leave it on screen for in case I need to take another break, but I should be good for now. Back to Coding Stream. So yeah, we just left off making this little enum and this little thing called a blep. And the idea is to make these dual IR filters. I'm going to need a way of flipping. Usually I keep a boolean and it's called flip, and that's what that does. Technically, if I've got that going on, I could simply use it. Might be worth it. After all, if I have the IR filter going on, then that will be present. If that is present, I can use it for all forms of interleaved things. And here's how this works. There. Now that is a boolean that flips each time, so it will be going at exactly the Nyquist frequency. So here's our gain control. Here's spiral, but technically what I could do is not even have that part. Like here's our output gain. Now that'll never happen because it's input sample not equal 0, but also false. And you never get to have false be true, so this never executes now. Easy to put back if I want. And now we can do, actually let's do it here. There. Now we have something to compare with. Here's our output gain trim. And now we can put stuff in here to execute using these variables. So if we do that, we have the dry sample, which has been done after the gain trim, but before output gain. And that means we're going to be able to run slew only on it. Yeah, here, let me show you. About this Mac, Intel Core i5, running Snow Leopard. Yep, this is where we do the original ones. The retro Mac stuff is developed on an old Snow Leopard thing, although I'm compiling for PowerPC as well. So here's where I'd like another one of my letters to show up. So So we're going to have D go from -1 to +1 because I don't know what polarity I'm going to want. But I should be able to get some kind of result out of this. Gain, input sample, and now we do a thing kind of like this. Now we have a hard clip. If we can make the hard clip work, we can make it work with any of the other ones. I just want to see what it does. It'll be interesting to see what this does. Excuse me. And see, that is available, so plus equals I'm going to want. So that's the difference between the two. And we can get fancier with this, but for now this is going to do. I'm going to go parenthesis happy just so that I know exactly what's what. So we have that amount and we are multiplying it by D. So it could be 0, it could be 1, it could be -1. And then we're also going to scale this back. So we do that, and then it will resort to 0 very quickly, or fall away very quickly. Then same, but the other one. And then we introduce it into input sample. Perhaps after there, or perhaps we just do it directly. No, we're gonna, well, hang on. You know, it shouldn't matter. I should be able to get enough mojo out of this. Maybe I'll do the sequence like this. There. Each new time coming in, we're dialing back what was already in the filter, adding this, and then we're going to apply it. And we apply it to input sample. And likewise with the other one. We don't have our high pass though. That's the amount of difference, but we don't have our high pass yet. And I'm trying to think of what I'm going to need to do. So what we've currently got, let's make some more variables. Let's make a prev sample A and a prev sample B. How about? In fact, we can simply call it prev A and prev B. It will now use these, and it won't have this anymore. And this is going to belong in this flip. So let's expand this out a little bit. So we're trying to produce the right thing to add to the IIR filter. And that means I'm interested in the rate of change between these measurements. Because if we're not clipping, these are all going to be 0. As soon as we start clipping, we're going to see something happening. But remember how that Signalsmith talk was talking about how you needed a high pass. And currently we don't. We don't have a high pass yet. So let's try to make one. Oops. So what we're going to do is take this difference and put it here. That's now going to be same. We haven't done anything to anything yet, so we get to work with the same variables over and over and over again. We're assigning it here. So what we're going to want to do is something kind of like this. And we could be building lots of intermediate variables, but I'm not going to bother. So now we have previous thing, and we're subtracting current thing. So if previous thing was 0 and we subtract current thing, we have a spike in a direction. If previous thing was going a particular degree, like for instance, if we have an angle, then dry sample minus input sample is consistently going to be the same thing. If it's consistently the same thing, nothing's going to happen with the output of this. And D shows us how much of the new thing is happening. So it'll look kind of like that. Alrighty. In theory, something has happened. We need to take this away. And we can pad the output. We have flip happening. We have flip selecting which of the two IIR frequencies are happening. And the IIR frequencies We could also be fooling with this in another way as well. There. Now we can also manipulate how fast it falls off. Just like that. We can even label some of these things maybe. We'll start that at there. And that at there. We could do that, meaning that's now unity gain. What are we doing with B? C is output, so we can do this for starters. We have ooh, hang on. I'm using D for the don't mind me, we'll figure this out. And let's see now. A was gain, was it? Yes. I do not remember what B was supposed to be doing. Why does it say 1.25 plus B times 0.01? It's a mystery. No matter. Presumably we're not using it for anything, so we're... Oh, no, wait. No. Hang on. We're using B, but it's built into Spiral now, which we're not currently using. But I'll label that, so now I know what it's doing. That's just a hard clip. Because the reason I have it that way is because I knew that the new implementation of Spiral is going to have a point at which it cuts off and doesn't continue getting louder. And I can explore using B to find that point accurately. Little note for what that was there for. C, what am I even doing with C? Does C have anything? Yeah, it's the output gain. And let's see, so we're already using D for that, so instead I had better bump everything up a bit. All right, hit a little save. Oh, I've misspelled that. There we go. E is, what's E? E is the amount. Oh, we got to update these. So F is IR decay. And E is the bipolar amount that we apply this. So we should see some action fooling with that one. And if it's set to 0, nothing happens. And there we go. And let's see, E, F, yep, okay. Hey, it built. So here's where stuff starts getting more amusing and we start being able to try this out. All I got to do is find a sound file. How hard could that be? We might not want to be listening to this, but that's fine. Ta-da! Note this one has noises, but this one does not because it is smooth. That's what that smooth control is there for. So blop amount is at 0 at the moment. IR decay is low at the moment. What's this spiral clip I'm talking about here? Oh, yeah, that's not affecting anything at the moment. So technically we should be able to get a clipping that is audible. I'm not seeing span myself at the moment. I'm going to pad this down. I don't have enough gain on tap to be able to hear anything happen, so let's fix that. We can have lots of gain on tap. And then let's see. Here is where we apply the gain. So we're hard clipping to that. We could make it be a smaller number too, but I think we're fine. And now I've got that sign stored here. And I've got the new plugin in Recents. Pad output right down. That is a hard clip. Now when we move this, something is going to happen. Okay, it gets brighter, it gets less bright. Looks like negative is the correct direction for this. So let's see what it did to the waveform each time. This direction. Hang on. I'm going to make it a little bit louder than that. Pat it on the speaker. There. So that's like pro-aliasing rather than anti-aliasing. And what it looks like is a little extra nudge on there in a way that's not supposed to be happening. So we've added a corner, which was supposed to be removing a corner. We've also made it tilted in a weird way. That's not completely as anticipated. we can make it sustain a bunch more too. Ooh, we made it sustain too much. Let's pad the output and see what we got. Again, this is fooling with things. Okay, that's what that made happen. We've got a weird result. I feel like IR decay is doing nobody any good going up that high. So, what would happen if we really didn't have any of it? We would have a hard clip. Hang on. Make it be a little taller. We have a hard clip where we can just barely see a pointy edge on the edge of that there. Because we're doing this. So if that is the wrong direction for this to go, what happens if we're at literally exactly -1? IIR decay will do something here. Well, it's producing a higher output, among other things. Wouldn't it be funny if we were playing with the golden ratio once more? So what do we have here? Spiral clip means nothing because we're not actually using it. We have a slightly rounded edge. And then IIR decay is still playing a role here, which I'm not sure that's what it's supposed to be doing. Like, to my mind, I don't feel like it should be changing the shape of the square. I feel like this should be tracking the sudden onset of something happening, but then not cling to that enough to sustain. What we should be seeing is that corner causing a high frequency ring for the purpose of smoothing off the aliasing. And I'm still not running span on it or anything. And I'm using this on literal hard clip, on nothing but a sine. Interesting. If there's no decay, then I do have my, well, no, I don't. That's not flat at all. That is actually still an angle. And if we're clipping to exactly 1, it has no business making these trapezoids here. So I think in order to make this work properly, I need to add another layer of indirection to it. So how are we going to go about doing that? Well, first we will undo all of that stuff and quit out of here. We still are producing a hard clipped sine wave and trying to cancel out only the aliasing components of the corners that we're adding. It should be possible to hear what it does as it goes. The IIR filter is getting filtered by F here. it's having the difference from the previous difference and the current difference applied to it. I mean, so now what I'm wondering, that should have been able to make it go flat. Dry sample minus input sample. Okay. One of the things that is happening is we now have an interleaved previous. That ain't necessarily what we're shooting for here. It might be fine. Might be fine, might not. Let's try another level. So what are we looking to do? Well, the IIR is probably fine. We're just feeding too much into it. Prev A and Prev B, it feels like that's not correct somehow, but what I'm wondering is whether I can feed in only the difference of, like, the way it's working, both of those are getting an input, but the clip point technically is only happening in one sample. It's one of those little corners. The corner only happens in one sample, and then it's immediately doing something else. So it should only feed into one of the IIRs, but it's feeding into both because we're doing a previous on both. That part's probably okay, but if we use this and it's simply not riding around inside the flipping part, then maybe that'll help. Also, I don't see why that's up there when it could be here. See? Now we get the original one and then we're clipping it, and that's the difference, and I want it as close as possible to each other just so that I'm sure nothing's happening to it, even though I know this is not running. That's the thing, is like if I put this up there and then engage this, then it would be doing the same thing but not on the hard clip, instead on everything that's happening in the spiral, which is a soft clip, so that might make it even smoother. But yeah, what we're looking to do here so we're going to try this. Notice that that's the same each time. What was that one that I just made? Unflipped prev. Oh, hang on. I'll get it. And have I also done this with it? Yes. I maybe don't need to make all of these variables all the time, but I'm making them just so that I can stay clear on what's happening. Oh, hang on. I keep missing steps. So we're going to do difference minus unflip prev. And now, regardless of what IIR we're on, we're going to feed that in, but that should only have one corner. That's running not as an interleaved thing, but every sample. So there should be only one point that the corner hits and unhits. And that should take it another level. Oh, but I also have to include it here. Excuse me. It'll build, but that's not what I meant to do. There we go. I'm not entirely sure blep, prev, A, and B are what I need, but we might as well see what they do. I have a pretty clear idea of what this is supposed to be able to do. Like, if I feed sharp corners in like Dirac spikes into this, Dirac spike is a single sample out of line, what I should get is a nasty ring at the Nyquist frequency without anything else changing. In other words, as you have audio going by, suppose you have like a square wave, but the first sample of the square wave is an even bigger spike than that. The output of this should be a nasty ring at the Nyquist frequency rather than like a slanted thing. So let's see whether we got anything like that happening. If I can get that happening, I can dial it in. Also, it'll be fun trying this on noise and trying this with span once we actually have it doing anything. Turn the output right down. We may have reversed the polarity of this now. Well, something happened. See what we're looking at. We do appear to have clean enough corners here. I can give it more output. Clearly, I can give it a little more output than that. Okay, that looks like something's happening. What does that look like now? Okay, we still have it doing a funny angly thing. I feel like maybe that prev is doing me no good. Maybe that also needs to be at the level of every sample rather than at the level of every other sample. Because see, we got it doing that thing. I feel like I see a little nubbin on the edge there, but not that significantly. And again, what I'm trying to do is make it worse rather than better to see whether I can make it do anything at all. And ideally, what I see is a little oscillating behavior in a way that's unhelpful because I'm doing it sort of backwards, but I don't see that, do I? That is not showing the oscillating behavior that I'm looking for, and we still have the trapezoid-shaped thing, meaning that this is not correct. So let's undo out of this. Let's bail out of here, and let's investigate whether the prev is not useful here. How should we do that? Well, this part's probably fine. So maybe we simply do it over again, but here. I guess one of the things I can do is try just adding it directly. How about that? Let's see what it does, because this part stopped being helpful. We'll cut things down and simplify. Now we're not making use of that A and B at all. We are making use of the fact that the IIR is interleaved. But now we're just adding this without trying to have that track in any way. I like how it's getting simpler. The dream of this is to have it be an incredibly simple little algorithm that I can put on everything. Of course, that assumes it works. We'll find out. And again, I am trying to make a high-frequency oscillation off the back of this that makes the aliasing worse. So I figure if I can do that, I can do the opposite and dial in what it wants to be. So let's see where we're at now. Ooh, our signal is higher. I feel like that can't possibly be right. We seem to have reversed the phase again. What are we looking at now? Oh. Well, that's not supposed to happen, but it's amusing. Well then. As soon as we hit a clip point, everything goes crazy. Because we're feeding the full amount of clippage into IIR decay is what? So technically that means we're still not seeing what I need to see. So there's no point even hanging around with that anymore. Haven't isolated those points yet. That's kind of the key there, is can I isolate the points that are departures from a continuous curve? Okay, so there's difference. What if I simply layer this some more? No. No. Prev. Here's our second layer. Hit the wrong key. Okay. So I got difference is the amount of clipping. Into layer 2 is previous amount of clipping minus current amount of clipping. Into the flip IR is previous that minus current that. I might have the polarity of these things backwards. Let's see what this does. One thing about it is at least it is another layer. And at some point this should give me the ability to throw ringy high frequency oscillations off of just those corners and not the amplitude of what's going into them. See what we got now. Okay, a little hard to tell. Louder this way, and this doesn't do anything. And IR decay is still quite high, so there should be a ringing hanging around on the edges of this. Oh yeah, That's what I was looking to see. Now it's hanging around way too long, but that's what I was looking to see. So it should throw that kind of oscillation anytime we get a corner. I might need to ramp it up, but honestly, the hard clip corner right there, that's not that extreme. Oop, now it freaked out. Let's not do that. We'll dial it back. So at this stage, we can fiddle with the amount, and we can fiddle with the decay, which doesn't need to be nearly as high. Look, I'll put it back to 0.5. And I still might not have all of this sorted, but now if we apply it, we'll see that there's this little overshoot there. See, it went a little past. And then it flattens out very quickly again. So in theory, I could put bipolar blep amount to the other one, and then it will soften that corner. Apply. And that looks very much to me like it has softened the corner, just a little tiny bit. I might need to add more of it. I might not have enough amount on tap. Now we get to play with span. But we have to make a effect stack to do that with. Here's that, and now we get to measure what it's doing. You can move over here where I can reach you, and boop. We have a result of sorts. We have a roll-off up at the Nyquist frequency that suggests it's trying to do the right thing. Question being, how does IR decay manipulate this? Hey, MC Mud. Well, we can add a ring to it. Clearly, that's one of the things it can do. So that can be too much information. Clearly, we have too much information available. So maybe we don't want as much of the decay. If we take the decay away completely, we can still put that little corner on there. And we have a different sweet spot. Oh, holy crud, look at that. See that 613? Let's find out what happens if it's 618. Wouldn't that be perfect? Yep, steady. And no, its maximum cancellation is somewhere around 626. and I don't think it helps very much to crank up decay. Honestly, no decay is doing something. So I wonder what happens if I gratuitously decide to put this back to what the golden ratio is, and then dial in decay and see if I can get a sweet spot there. Not all that helpful, honestly. Tiny amount of additional decay in there. So here's the thing. I know that having some IR decay in here should be useful because this is my resonant interleaved filter. So we'll get a little saucy here and see what it does when we have that. Once it resets, it becomes hiccups and needs help. So the way this is working, as I go into the hard clip point, it does appear to be resisting. It's a little hard to pick out where it kicks in, which, considering that this is a hard clip, that's saying something. Let's try another variable in here. If IR decay is 0.5, then it retains the mantissa of the new thing that's being calculated while adding something else to it. Okay, that seems to be where it's noding out. It has nothing further to give me. Some kind of soft clip. We've got some kind of soft clip going on there. So if we apply it and then hide span, here's what that looks like in practice. Nice soft, nice flat tops on the waveforms. There's that. And then not what I would call a dead obvious corner there. It looks like a very clean, accurate corner, but we've got that little in span there. It's doing something special. So as long as we do have that open and available, firstly, let's throw some noise at it. Let's watch this again. So I've not touched anything else. Let's pad output down. Oh, I've got a bit of an extra edge there. Okay, so what happens if we leave IR decay the way it is, but fool with this 56 was where it was at before. Oh. Well, that's different. Didn't expect that. Clearly, these other settings are not the node we're looking for. And there's not that much going on here. But this is on the opposite side of what the previous one was. Okay, so what if we start throwing a bunch of decay on this? What happens? Get a lot of sustain. Is there a place where this now does something useful? Not really. It is pretty sensitive, to be honest. I feel like the waveforms are going to be better than this noise. I feel like this noise is not really doing what I'm looking for. So here's what was working on that sign. Not necessarily thrilled with what it was doing on the noise. I'd better just go and open something else. Let's do aliasing on alien kittens at 44.1K so we can plainly hear it. Assuming we do get to hear it. Remains to be seen. Here, I can let that be a little bit louder. It's dragging its feet so much and Span's useless to me now. You settle down. Okay, well that's kind of interesting. Do I get a big obvious change if I start fooling with bipolar blip amount? And this is nothing. That's what I had previously. I don't know, Bessa. I'm not sure how well that's working. Here, we'll quit out of there for the moment. In a way it's working, it's just a little difficult to sort. So I've got IRA at 0.5, the way this is currently going, and that seems to be doing fairly well. The amount we're adding to it, however, is very different. Also, I'm not entirely sure whether I should be doing this the other way around. Like, what if we start with the unflipped and subtract the new information coming in? Does that act different, or does that just flip some polarities around? So I'm not sure that should be any different, but we are doing 2 layers of difference. I mean, we could go full hog and do 3 layers of difference and see if that goes anywhere. No. No, it should not. Spiral clip is not supposed to do that. Also, we don't actually have a spiral running at the moment. We're doing a hard clip and measuring that. Because a hard clip should show very clearly how this part works. No, not like mod x plus 1 minus 1. I wonder how many levels of this I could add. None of these are flipped now. Boop. So we'll do A, B, and C. That should work. Let's see if I can master the pattern. And then let's keep it going and see how far we can go, whether it does any good. Technically, this is continuing to respond to, I guess, deeper and deeper splines. Guess that's what that's about. And we add that. I mean, technically, we could modulate this divisor as well, but what I'm doing is leaving it at 0.5, just because that's a clean way of continuing to step it downwards. Pretty aggressive way. Also, I get to crank it up a lot if I want. And let's see what we got. Also, I can't help but think I could do this. And then just rename these. Oops. There, now doesn't that look neat? It looks well organized. Whether it's doing anything useful is a whole other story. But there's a certain aesthetic to how ridiculous it is. And if it actually works, that's a whole other level of nice. But we don't know whether it actually works yet. But it's fine. That's what experimenting is for. Because if it works really well on a hard clip, it should work even nicer on spiral. And before 16 times the difference layer. Yeah, I know, right? Let's make all the layers. Back to our original sign, I think. Now let's see what it's even doing, if any. So what are we looking at now? Okay, that's presumably the opposite of what it's supposed to do. What do we see? We see what looks like a up and down ripple. It's kind of hard to see. I need my glasses to see it. But that's kind of what I was looking to see happen in this kind of scenario. In fact, there's the ripple coming off of that change as well. Cool, cool. Like that. It's hard to see, but it's not necessarily meant to be the biggest alteration. That when Signalsmith was doing that talk, he had to draw stuff up so that people could see the curves, but this maybe not so much. Now, if we was to do the opposite, we do end up getting to see about the same thing, except for it is definitely softening the attack. So since we know this is the wrong thing, let's crank it up a bunch so that we can see it ring real hard. There we go. That is a substantial Nyquist frequency tail on each of those corners that are the result of one corner being applied to all of this. So then if we flip it over, we still get to see that sharp corner, except for, I believe that is now on the underside of the corner. It's softening the attack. So I think it's time to go and look at what it's doing. And span again, if I can operate the controls of this crazy machine. Come on, you. No effect stack. Recent things. There we go. Recent effects. Spiral 3. And span, which doesn't like running on this old machine, but what the hey. They do nothing. They're just sitting there in case I needed them, in case I need to put another variable in. So what we've got here is obvious aliasing. But that can probably stop being a thing. Oh, and see, it gets larger, it gets smaller. And maybe decay. Oh. We got a steeper drop off over there. So I'm very distrustful of the way that IR decay is behaving. I feel like when I have it ringing that hard, it's just interfering with things. So technically, maybe we don't even want to have that there at all. Or maybe we do. But if we didn't have any of that, various things might become a lot simpler. What do we need to do in order to get it to do something now? Well, we're getting to have more of it, and then this direction is clearly the wrong direction. Although weirdly, now we're getting a cancellation in here. That's not expected at all. See? It's got extra energy here, but then it's rolling off more here. That's deeply weird. And then this way we're just boosting. So and then when it resets, it gives me a bit of a fit. So if we had literally no decay on it at all, that would be interesting. Might get in the way of needing to do the bear with me. Okay, that's 0.439. Pretty sure as soon as I bring any IR decay into this, it starts not behaving right again. Suggesting maybe we do want that not to be on. So here's where we get a little messy and doubtless shut off the speakers. Sweep up. I don't know what sweep up flat means. Like I said, shutting off the speakers for this one. Interesting. Okay, we do still get aliasing right up at the top. But as we're approaching it, okay, that's obvious, but then what happens if we start fooling with decay? What if we give it the 0.5 decay? Oh no, I'm sure I haven't. That wouldn't be what this is. And there's a bunch of highs noise in there. We'll kill the decay again. What if we only barely hit distortion? See, now we're not distorting. We've got a hard clip ready to happen, but we don't need to hit it very hard. There. So we're just barely kissing the edge of the hard clip. I feel like I can dial this in better. So if we just clip that really hard and find the blep amount here, what happens? That's not right. That's not right. It can't be that. That is literal nothing. Seems very sensitive. I'm not sure I'm loving this. I'd better go back to my original wave. We shall return to that one in a minute. So no distortion, a little bit of distortion. Okay, so if we do that, we can pretty much cancel out that moment almost completely. The adjustment is so delicate. Well, I can be cute, and we'll see if we can make it work based on a golden ratio of IR decay, just because why not? Just because, who knows? Let's see what happens. And that's a respectable amount, so we're kind of masking the point at which it hits the edge. Even as we go fairly hard into clipping, we seem to be isolating that corner and softening the corner. So now that we do that, we open up the crazy sweep thing again and see how it reacts to this. I'm still getting some aliasing, but I feel like it might be less. So let's compare this with not applying any. So 0.475. This is no effect. Honestly, I feel like maybe that was a little bit louder than it was before. Let's loop that bit. Let's zoom in. Okay, so 0.475 previously. Does it become better? Honestly, I'm not sure that sounds any different. So what can we make happen here, if anything? Maybe this is not where it's able to do anything. See, one of the challenges I'm looking at here is I am trying to apply a filter at Nyquist on the same samples it's reading from. So I don't have a higher sample rate to filter from. That's a bit challenging. Although there may be ways of working around that. Such as using the fact that I'm dealing with these things in pairs to soften stuff based on how much is happening. We could dynamically apply an averaging filter on pairs of samples to see what would happen. Stranger ideas have happened. So the IIR filter stuff, it's being able to soften tiny edges coming along as we go into hard clipping, there might still be use for that. I'm going to take a moment and play with not running as many of the layers as I was. That's fairly straightforward at this stage anyhow. Also, if I'm not running a continuing, like if it turns out that having it be an IR filter is not useful, we can just apply the layers of these. That would be kind of interesting. I'm now speculating on averaging within the flip using previous flip samples, using previous interleaf samples. That's more like 11K or even less. So if I am averaging between adjacent samples within this flip area, that gets aggressive. That gets very aggressive. And I do have F available to calculate that. So technically we could try it. Ooh, Wayne and Riders. Well, I'm glad you're enjoying it. I mean, what can we do but continue to fool with these things to see if we can get anything to happen? Oops. I'm stepping back to this level again. But now IRA and IRB are going to be the previous input sample, because we're going to do a little crossfade. So that's the same as not having any sustain on the IRR. Don't mind me, I'm making a big mess. I'll eventually stop making a big mess. So do this and we apply the thing just as if we were calculating it directly and then using it, which technically we could do without any of the rest of this. Because if these are exactly the same, that can live there. And then here's the interleaved part. Or that could go after and we can do a thing like that, except for not that either. Not that either. No, no. Especially since we're using F on it. That is absolutely no bueno. Okay. So obviously not that. Not even close. No bueno, not a chance. No way. But also not this, but we're getting closer. So if we were going to do a dynamic crossfade between two samples previously and the current sample based on how much of the layer stuff is kicking up, and we also don't know whether we're going to be using layer D, C, B, or what on this, but, well, no, it wouldn't be layer A. That is the lowest quality. It's the smallest, most useless part of any of this. So we don't want that. Layer A is literally just how far are we distorting, and that's the last thing we're interested in. So these are going to be input sample times 1.0 minus layer D, except for maybe it's going to be layer C or even B. Not sure. And see, now that we've done that, we can bring in the previous one, which again is not literally the previous one, but it's the previous one in the IIR filter. So we're softening it based on that, and then we're adding layer D times E, which is the thing where the polarity keeps varying and it's hard to tell which direction it's going. Technically, we should put that on another knob too. Or what if we did that? Then we're applying it as before, but that's also what is trimming it. Well, I guess we find out what it does. Nothing to it but to do it. Let's see what it did. I'm tempted to go straight to the high frequency sweeps on this one, because it was always behaving nicely on the low frequency stuff, but the high frequency stuff is the stuff that's giving me fits. Sweep up. Let's select a section. %, supersonic. Good, good, good. Make an effect stack every time, because why not? It's only 2 things in it. There we are set to cause havoc and to see what it's doing in span. So this is going to immediately be really bad. I don't remember whether decay is doing anything anymore. Actually, I can check. Yeah, we just got layer D. Layer D times equals E. We no longer have an IIR roll-off at all. This is just doing a filtering. So what do we got? Yeah, this was F. Doesn't do anything now. Oh, causing something to happen there. Okay, we can make it louder by having the levels be wrong. We're distorting harder so we can hear it more clearly. So here's no effect. Well, that was fun. In that way, that basically just broke things. Okay. We're having some fun playing with this craziness. So this would be nothing. No distortion. And no effect. Okay, that's not getting anywhere. Let's duplicate this stuff so we can use this one, and we'll adjust them separately and see if any of this makes it act different. There. Now we get to have F be bipolar as well. So they can be even adjusted in opposite directions if that is what it needs to be. And then just for laughs, let's assume the smoothing factor maybe wants one fewer layer of layer. I just got a sense that the steepness of D is okay for directly applying to things, but then this softening factor needs to be a lot less steeper. It's just noise at that stage. And of course, now that we've used it, we can scale it back because we're using it here the second time. Okay. I may or may not get any results out of this today. I just know that I'm doing the experimenting I want in the most difficult possible way, because if I can make that work, that'll be neat. It may not be a reasonable thing to expect. I'm not sorry I'm trying it, though. Spent all day like ripping CDs and stuff, so we might as well fool with this and see if anything happens. Back to effect stacks. Now that is doing nothing. So let's see, 475 was a previous optimal setting for bassy frequencies. This one might be something else entirely. Oops, not you. So no distortion and we are fine. Kick in the distortion and we start getting lots of aliasing, which is the thing that we're trying to remove. So what does this now do? It's now running at a more coarse level of this thing we're dealing with. Okay, that made it louder. Trying to tell whether either direction is doing the thing I want. It's a little hard to tell. Can't say as I'm all that satisfied with where that's at. I'm reasonably happy with how it's acting, softening the single clips that are really far away from aliasing. The thing is that as soon as I start throwing edges onto stuff that is already like the first available harmonic is going to become aliasing. It's like I can make it suppress aliasing the tiniest little bit on some of that stuff. But then I run into problems here. So back to the drawing board, I guess. What if we didn't flip at all? What the hell was that? Okay. There we go. So that is now two separate well, when we get to add layer D, what if we softened using a bunch of these? See, that should be cranking that stuff up even more. Technically, we could still go back to doing this. That's something that could still do. It's no longer an IIR, but that's fine. It is a feedbacking averaging filter, though. Which is arguably an unhelpful concept. But now we get to see what's going to happen when we try this. Also, bearing in mind, layer B times F, first of all, this could be modulating, and I might need to be using an absolute value here. Could very easily be modulating, and I should be using an absolute value here. And secondly, if it's not modulating and I'm not using an absolute value here, I'm simply inverting it. And if I'm using a negative value on this, everything becomes a little strange, and that's probably what was happening. Okay, one obvious way to deal with that. Actually, then there's no reason for F to be I'll put it back then. F, 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 F. There's no use for F being negative anymore. Don't be negative, F. You're going to just go from 0 to 1. If my typing can handle it. There we go. Alrighty then. We changed a bunch of things. Something's going to happen. So this at least is an interesting approach. It does seem like I'm isolating higher and higher levels of spline corners. It's just that the rest of it makes no sense. But now we're doing multiple levels of averaging here at 2 different degrees of isolation or something. Let's see what it made. Might just be a silly mistake, in which case it wouldn't be the first. Let's even see what it does. And span. And that starts out as 0. That's our previous correct setting. Okay, we can make that lots louder. That's super unhelpful. So maybe that's not the right thing. What if I tried it at a different pitch? Are there areas where it's happier? So this averaging stuff feels like it might be a bad move. Although, I mean, I'm doing IIR, so what I could do is simply have it be triggered by activity, and then it would act more like a high-frequency limiter again. My trouble is this doesn't make any sense. So what if we literally ignore all of that and just bring in multiple layers of filtering? This has now simply become an averaging filter. Ain't nothing else to it at all. What happens when it reverts to being an averaging filter? Although technically, you could also have it kick in on layer A. If it was on layer A, absolute value of layer A It's an averaging filter that only happens when you are clipping. That almost kind of makes sense. It would stop when you were not. But let's see what we get when we are actually just setting the amount of filtering with the knob. Ooh, also it is time for me to attend to some things. It is 4. Alrighty. Aliasing. Can we make that stop happening? Well, not once it starts aliasing, but something happened. Technically, this is full-on it's basically just clinging to the saved value. Yeah, it's like it's filtering the output. When the aliasing sweeps down to a really low frequency, I can no longer filter it. I don't think I can actually address this unless I was doing this filtering before the clipping was happening. But stranger things have been known to happen. So that can be a little glimpse of something happening. Wonder if it'll let me do bass. Yep. But if we do this, we can't even get the low frequencies anymore. Back in a moment, I gotta thaw out some cheese. I'm back. So, what we've got here is a pair of averaging filters after the saturation. So now one possibility is if we were doing an averaging filter based on what was happening in some perhaps delayed way before the saturation, that would potentially be suppressing high frequency information before it got to the clipper. Just in time for the last bit. Fair enough. Yeah, this is not necessarily one of the grand successes, but you know, it's a thing. We're going to see. We're going to see what is happening. And one of the things that's happening is that we are, well, I've got stuff stored in here. Right now, I could simplify this down a little bit. By using this. There. Now I have a continuing sample, which is working as the would I be doing this before the dry sample or after? Let's try after the dry sample, but before the clip. Now, this has to be an absolute value. But it could be one of these. We don't need it to be both of them. And we don't need that to be that. And we don't need that to be that. And we're already using layer D because that did a pretty decent job of like taking the edge off of some normal clips. I do wonder whether some of these should be absolute values as well, but you know what our IRB now is that. So I feel like it's time to, well, do we have F doing anything? We don't have F doing anything, so I'll tell you what. We'll have F doing something after all. We'll have F select between these, and then we'll hear what that does. And that'll give us something to do. You know what? This doesn't have to be as complicated as all that. we'll just repeatedly reassign it. There. So if it's down at 0, then we start at A. If it's over 0.33 but isn't over 0.66, we end up with layer B. If it's over 66, we end up with layer C, because it's just assigning it in a little row there. That's as good as doing it properly. Now, whether it does anything useful is a whole other story, but what the hey. And we are doing the absolute value, so that at least is going to work out okay. And we're not scaling it in any way, but maybe it'll be okay. The other three letters are the amount of density in each of those categories: loudness, detail, and fullness. For a whole bunch of the ones that I've measured, those like to be G's or H's. So don't you be worrying about trying to make all the letters be A. If the first letter, the letter score, is plus A or A, you're probably doing just fine. The other ones should match each other. That doesn't mean they have to be high. They're just a measurement of how dense everything is. And it seems to be, I can't show you now. I don't think I have time for today. But I promise to you, a bunch of the stuff that was actually really good sounding, in particular, I went through a bunch of police records and a whole bunch of extremely good tracks that were police hits all ended up with quite high scores, but the three-letter part at the end, they were all hovering around G's or H's. So that seems to be a sweet spot for densities to use. So let's see about this. And let's see what my screechy thing does. Sweep up counts as my screechy thing. I keep looking for an effect stack, but I do not have one. Here's F. Alrighty. Okay, we are applying it very aggressively. I tell you what, that tells me all I need to know. Chirp. Need to scale this now. That means we need yet another control. So guess what? Double G equals param G. It all seems to be doing its job. Oh yeah, no, I'm trying to... Signalsmith came up with a way of doing a new kind of aliasing reduction. And I've been playing with the general concepts, and I can't say as I've been really getting anywhere, but I did get one nice little thing where I can soften the attack of some of the darker transients. Like I can soften the corner of hitting hard clipping quite effectively, but only at lower frequencies, and that's what I'm looking to do, is deal with a way of making it deal with higher frequencies. So G, param G, we got G. G is available now. Now we apply it. Now if G is at 0, we should have full crank. Yeah, technically I already have a new spiral because I have a new spiral based on longhand. And I have every reason to believe that that is going to be good. I'm just real curious about... Actually, I've already gone well beyond everything learned from... We're not technically doing the thing, but I'm doing a different thing, so what the hey. The thing I was trying to do based on Signalsmith's work failed and did not work. I was not able to implement what he did. So I'm seeing if I can do something else. And we're doing it the most difficult possible way, which is by running a ultra high frequency shriek into it. Which is why I have the speakers padded so much. Just like the cell I belong in. Here we go. There is our full aliasing. Full crank. Bipolar blep amount is still at the thing which was working best for us on the base frequencies. Now as we start adding G, some of this is going to be softened. Or maybe it'll just freak out. That's interesting. Okay, it looks like we permanently cut down the volume. I don't know why that happened at all. Can we go back? Yes. Okay. So again, back to full aliasing. This is going to have 3 settings. Each of them is going to be a different place on this calculation. Okay, that was aggressive. I don't know what happened there. Okay, it snapped it to something and stuck there. That's interesting. What about in the middle setting? Okay, that time it made a bad noise but didn't stick. This is not great. It's not behaving itself. Better than this. I can make it snap into basically full crank and get stuck there. So I guess my first question is, why did it get stuck there? Should I be clamping it? So layer C is one layer below layer D, which is the output on it. If I bring it up too much, I do get to override this though. So I'm going to suggest that blep IRB being higher than 0.5 is never going to be useful. And in particular, if it goes above 1, that's guaranteed trouble. So I'm going to explore the idea of limiting it and leaving the rest of this where it is. There. So it's an absolute value, so it can't be lower than 0. And 0 is not a problem. 0 is fine. But now we're stopping it from ever being more than a equal balance between input sample and this previous, which is IRA, and IRA is literally the previous input sample. I do wonder whether maybe I'm doing it wrong by not checking, like maybe this should happen before dry sample because we're changing it, but then the rest of this stuff keys off of the difference between dry sample and input sample. So maybe instead of that, it wants to be more like this, where it's only caring about what distortion is happening, if any. And so this filtering can take it down below the distortion, but the filtering itself does not feed into this whole mad shenanigans. And let's see what we got. One thing about it, it's all very simple code. That is a nice thing in that there's so little to it. And honestly, even if I'm only able to soften the corners of things going into a hard clip, there's still something to that. I had that doing useful things on just bass notes, and I was able to do nice things to the Nyquist area. Although it was all very quiet, though. It was only interacting with things in the very quietest of quietness. What we're trying to do here is interact with things in the high frequenciest of high frequenciest. Namely here, where we pretty much can't even hear it without distorting it. And it's a 96K tone, so, or 48 rather. That's how high it'll sweep up to. Add effect. Here's spiral 3 once more. This time it should not flip out and choke. Let's see how true that is. Okay, that's amusing. Here is the full volume aliasing. And here's what we did to it. So if IR decay was set to different things, we get this happening. So it's kind of squelching. Well, it stopped blowing up anyway. I appreciate the fact that it stopped blowing up. I really do. Middle setting. I almost would tell you I like that better. We do get sort of a choke in there. Third. Okay, that's definite squelch. Here's a thought. What if we pick the loudest of each? It's getting gnarly. When we do this kind of stuff, it is getting gnarly. Also, we can exaggerate it in a mimetic way. We'll just make it go to golden ratio for clinging to the previous sample harder, but it still shouldn't choke. It chokes when that value goes way higher than that. But what if I'm debating whether to try to do the max of any of these or to simply add them all together and multiply them by G. We can but try. We'll find out. Ooh. I should totally also include layer D. I've got it. Nothing's stopping me from try it. Sure. Sure. Let's give that a shot. Let's see what we get. And then all I got to do is add the pluses in between all of this, and we'll have a something that's probably going to be much more sensitive, but that's why we're multiplying by G. We could multiply by F if we wanted to, but we don't have to. Yeah, I mean, why not? Literally, that's what I'm thinking is why not? That's probably going to be satisfactory. Can't but try. Let's find out. It's definitely a kind of fun just throwing this sort of thing against the wall and seeing what sticks. The hope, of course, is that something cool will happen, although I've already kind of given up on the IR-based stuff that I was starting with. Signalsmith's help did not end up helping me at all. I don't have the math to do his thing properly, and my attempts of doing it improperly did not work. But who knows? Maybe it'll work in some future day. Maybe I shouldn't give up on that quite so quickly. Anyways, part of it, a little bit of it did, I think, do some use. Which is a strange way of putting it. A bit of it kind of worked or something. That's why bipolar blup amount is staying at 475. So what do we got? Well, that doesn't do anything. G is the one that does something. Here is the default. Oh, I'm moving the wrong one. I should be moving G. Bear with me. Oh, we managed to make it much louder. That's not really desirable, but what the hey. Something happened anyway. Oh hey, if everything is completely maxed out, then it's suppressing everything up to a certain point. That's kind of neat. I'm still hearing all that aliasing though. Yeah, it's a bit of a wild beast, this. I can make it suppress everything real violently, but then it flips out at the last possible moment. And if nothing actually clips, we're fine. As soon as it does, things get a little messy. Yeah, see, this being actually much louder than the aliasing is not good. So maybe instead it acts like there's a time constant involved. Like that. And then we can cap it at halfway again, because it is there to stop aliasing up around Nyquist, and every other sample is Nyquist. And seeing as we're adding that to it, getting it up to 0.5 max, we also need to dial it back too. Which is doable. We'll have it fall back very aggressively. We could also have it fall back much more slowly. Unused variable f. A. Okay, let's shuffle these around then. It is in fact G that we step it back by, and F for all of these things added together. And again, like layer A only happens when we're clipping. So all this stuff is increasing layers of fuss over the basic concept of now we're clipping. And now I've got G hanging around. And I could apply this in this equation. But if I apply it here, it'll fall back out much quicker. So we'll give it a try. I can't believe I've got 20 more minutes till dinner. Better than 20 minutes past dinner. I'm still doing it though. I will try to do the self-care thing, and even if I have not succeeded with any of this, I'll still go and have dinner like a proper, reasonable, healthy person. How can you not? We just got one life to live, and I live it struggling with aliasing, by God, but also having delicious tacos, so there's that. And yet we've not actually heard spiral at all any of this time. We're doing this with a hard clip on supersonic frequencies, so it's like the worst possible scenario for literally everything. Just because I'm being difficult. I'm making it be very difficult. So here's where we turn it into nasty, snarly effects. And here's where we sustain the grind. Here's that 0.5 I was going to use. One thing about it, I think we made the aliasing a lot quieter. This is without any of that being applied. Yeah, feeding myself will happen in time. The crunchiness is a lot less aggressive now, even though we're clipping real hard into aliasing. So if I set this to 1, it'll be stuck at filtering. And that means the level will cut back as amplitude increases. And we're seeing that happen. See, we have distortion until we don't. Go harder, and it goes a little farther into the aliasing. So this is amplitude dependent. This will clean up highs up until we hit aliasing. We can turn that up too. And see what I said? This is on full crank at all times, so this is built in. But if we dial this back a hair, it starts getting gnarly again, like this. So what kind of behaviors can we make it do? There. So that was an obvious birdie. But if we start including this, it chokes off that birdie. It's not able to go into the lows anymore. But now it is. I wonder whether I can get fancier with this. Like, it's kind of working. Here, check it out. If I go back to the base, that is a nice smooth saturation on that bass there. So that's just a sine wave being turned into just about a square. And if we don't clip quite so hard, and there we get into that slight gnarliness that is not low frequency birdies. So that's kind of interesting. Also, Geo, I don't know what you mean. Nor do I know what grizzlies are. I'll reply to you, hello. And I don't know what you mean by plucks. So I guess we are batting 0. Let me get back to here where I'm also batting 0. I'm wondering whether we can just change all of this stuff around and whether multiple layers of sampling would help. So there's one thing I can do in here that will get me a different result anyhow. And that is this. If we keep this IRA and IRB, but stack it up, actually it's I fear I have that wrong as well. Oh, no matter. We're on like 96, I believe, on that filter. I was looking to do 2 of these, not just 1. That's the thing. Well, then let's use the IR as well. And we'll come up with something amusing to do with all of this. And then we're going to do average A and average B. Might as well. And then we've got prev A, B, and C, and then total. So we got to do average A there. And now it'll work the same way it did before, but then we can do this. B throughout. Now we have 2 layers of average and filter. That should do kind of a lot to help suppress the high frequency aliasing. 1 layer is already a lot against a Nyquist frequency. 2 layers, that's going to be even more. But then since we haven't defined IRB in any way, we can simply duplicate it like this, and then we will modify how these are loaded up. So they can both max out at 0.5. I think that's fair. No problem with that. We can multiply both of them by G and have these driving factors be driven by F. But we can stagger what's driving them. I'm not sure I want it to be in that sequence. How about I reverse that? B can be the more chattery one. And A can be the one that is closest to triggering just on are we clipping or not. Technically, I could do 4 layers of it, all based off of one of these, and that would be amusing in its own right, but I maybe don't need to do that. And I guess now we see what we got. I've got enough knobs to put all of these things on a separate control, but then I'd have to go and label them all and stuff, and it would be tiresome. Let's go and see what we got in our last 10 minutes before taco time. You don't hear any sound because I'm not making any sound. Not right now. I'll make sound in a moment. Also, we're not hearing any sound because I'm flinging like upwards of 20K into my monitor speakers, and I don't want to break them. Like this. That's the sound. But now you can't hear it anymore. And we're going to be running that straight into aliasing and making it be really horrible to hear. So, because that's just how we roll. Effect stack. Then this band is handy for this stuff. And now we're not getting any aliasing because we've basically suppressed it beyond its ability to respond. So G is how easily it can spring back. If G is all the way down to the bottom, we're going to get a lot of scrunchy noise. So that's neat, but kind of aggressive. So I feel like we don't need to do the beginning of this sweep. We can already tell the beginning of the sweep is just straight up distorted. So instead, all the highest frequencies. So if we're only distorting a little bit, oh, hello. If I push this in less aggressively, it's gentler sounding, like that. And this is straight up just plain aliasing. When it swoops down to the lower frequencies, that's when it's more obvious. When G is lower, that means it springs back faster, but that's why we're hearing the scrunch. Interesting. Now you can't hear anything because I'm suppressing the aliasing better. So pretty much everything we're feeding into the distortion now is part of full-on aliasing. I cannot generate any harmonics here. I cannot generate any harmonics without them making an unpleasant noise. And yet, I'm still hearing that frequency. And then this other stuff is not noisy and it's not deep. Not like this. So here's some gentle saturation of like about 6 to 12 dB of distortion. And up we go into the supersonics. And it doesn't fight as hard. Mind you, I'm still hearing it. Here we'll go even harder. Now we're definitely going to hear it. So those are the birdies, but this is what it would be without any of that. That's a lot louder than this. So that's all quite amusing, but what would that be like on music at that level of gain? Well, we can start by bypassing it. Alien Kittens at 44.1K. So this is how much gain we were doing in order to get that. So we added this much gain. And what it's supposed to be doing is trying to resist aliasing. It's definitely a lot of gain. And then we got something out of all of this. It's a big mess. It's certainly not what I intended to do when starting out. Definitely a messy thing to try, but like the hats sound about like what they did. Everything else gets real chunky. What if we play with this a bit? Pretty interesting. I want to throw additional things at this. Like same but 96K. It's at 96K, but it's upsampled from an original, so that's why 20K is looking the way it is. Fair. Then some noisy rock music or something. I've got that, right? We can use this. It is a firewood pile in the background, yes. Yeah, I can get it to absolutely choke up there. That's amusing. Alrighty, well, we'll grab a screenshot of that so I remember those settings. And yeah, I'm done for the day. I admit I might not have got done what I thought I was getting done. Something happened, though. I'll be working on whether I can make any more sense of that going forward. The underlying stuff before I got into the suppressing high-frequency aliasing when it's incredibly loud, and I tried valiantly to do that. But the underlying thing kind of sort of worked. I left that in a basically working state, and it was kind of behaving. Aurora, no. No, not Purist Console 4 this weekend. Understand that part of what I'm doing today, or didn't successfully do today, is looking to come up with ways of suppressing aliasing on things like Purist Console 4. I'd like to get it even better before I put it out. I'm no longer satisfied with just having it be like the longhand version of Purist Console 4. I want to get this kind of stuff working better before I can throw it. And I don't know if I will. It's worth a try, though. And I'll see what I can do. I will be back again next week. Probably we can do more in the way of these coding streams, because I've done my synth jamming and showing other people's plugins and stuff. We're back to my plugins, because I just have a feeling like this thing with the I got really close to being able to get something happening with it. I think I got distracted by trying to throw wildly distorted supersonic waves at it and have it behave itself. That might be too much to ask. Maybe I need to dial back to the interleave filter thing that I was doing in such a way that without trying so hard to fix itself, okay, so here's where I'm at. Oh, also, as long as I have the camera up, I'm working on the stomp boxes, yeah? Well, I'm learning how to do graphics on them. And so there will be a painted surface for a logo. And this will be the sort of hot diamond box. And it's partially in the process of being painted. And I'm working out how to do that better. I'm using the masking, as you see here. And I'm coming out with ways of doing my logo there. Also, if you stopped by the Circa and Descent stream, you were hearing that stomp box the entire time I was using it as a DI. So if it sounded pretty to you, it wasn't just a Stratocaster into an API. No. No, it was a Stratocaster into the stomp box into the API, because I was using the stomp box as a buffer so that I could get a chimier, nicer tone. And Visa Jam SC, yup. I was using this. This is the most recent version of it. I had these clipping diodes on there, but I'm not sure if that's actually going to be the final design. But this is what I was running all... what would that be? I guess that would be Tuesday. That was Tuesday. Yeah, so all the guitar on Tuesday was going through that. They will be built into these little boxes with a little brushed aluminum finish. And the first one gets sold for $100. Every successive one is 6.18, etc., % more than the previous. So we'll see how many of those I do. And I'm thinking I'll have a variation on it, and that'll start at a separate $100 and go. So yeah, it's been a long day, and it'll probably be a long tomorrow, etc. I'll come up with something to do for Saturday. I'm sorry that it can't be Purist Console 4. I really made some progress with it, but now I want to include something like this. I want to have something like this in there as well. And I feel like I got derailed trying to run test tones into it. And I should know better. I should know better than to get derailed trying to run test tones into the thing, because it's like, that's not how these things have to work. I don't have to run test tones into it. I can run music into it and tune it for that. But it was a day well spent, all things considered. And I'll see how much I can get out of it. But until then, time for me to be allowed to have tacos and get some sleep, and I'll get right back to things. Next week, more coding. We're going to jump back into this, and we're going to do more coding. I'm going to type up a bunch of notes from where I left off, and we'll see what we can make happen. For now, I'll talk to you later. Bye-bye.